Hey guys, this video is going to be about functions. I'm sure you've come across them in high school and I'm sure you've seen them before. So usually they are denoted as so y equals x or some other value, some other formula or equation. We might see it as f of x equals x in some textbooks. I'm sure you've seen one of these in your books. Anyways, with our functions we usually graph them, but let me first explain what a function is. When we input a value into a function, we get an output value, which is some other value. In this case it's 1, so we input 1, instead of x we write 1, and we get y equals 1, so that's our output. With more complex functions, y can equal x squared, or y can equal 2x. Let's go with this case. So if I input 1, I get y equals 2 times 1, y equals 2. So I input the value 1 into our formula or equation, and I get this other value, which is 2. When I input 2, I get another value, which is 4. I do have functions where I cannot input any number or a specific number. So if I have a function like ln of x, because of how this function is defined, it's not defined for numbers that are smaller than 1, then I cannot really input a value like 0 or -1 or -2. Therefore my domain, all of my x values, are limited to a certain subset of R, real numbers, or in more simpler terms, I cannot use all the numbers on the number line in this case. So we already know what a function is, and now we're going to try and graph one, because you'll see that in mathematics we do this quite often. This is my x-axis and this is my y-axis, and I'm going to graph the function 2x. So I've put 1 here. Then what happens when I input the value 1? I get the value 2 back. Just put a small dot here. Then I'll put 2 as my x value and I'll get the value 4. Now I can input a value like 1.5. 1.5 times 2 is 3, so it's somewhere here. You can really put values like 1.7 or 1.8, 1.9, and you'll get really close to your 4 on your y-axis, or you can put values like 1.4, 1.3, and you'll get really close to your value 2. But this is not a topic I want to be speaking about. If you connect all the dots, you sort of get a line at a certain angle. You can see very clearly it's at a certain angle. Now I'm going to show you the equation for our function, for this function, y equals x. So if I input the value 1, what happens? I get 1 back. If I input the value 2, I get 2 back. And you can very easily see that this function is at a different a different angle from our function 2x. Now, we graph functions to notice their properties better. It's easier to notice their properties. So, in the case of these two functions, what is the domain? Basically, which numbers from the x-axis have we got on our functions? So we've got 1, we've got 2, we've got 3, we've got -1, we've got -2, -2, and this goes into infinity. So we would say that our domain of our function is from -infinity to +infinity. Notice that my brackets are curly, meaning that infinity does not belong there. You can never reach infinity, but you can get infinitely close to it, which might sound very hard to imagine. Then the range of our function, which is basically all our y values. So this is our x values, this is all our y values. So if you have a look, how many y values have we got? You don't have to input numbers that are just whole, like 1, 2, 3, but you can input values that are like 1/2, 1/4, 1/4, 1/5. So rational numbers, which is denoted as a q. So I think you already know that our function is going to go from -infinity on the y-axis to +infinity on the y-axis. Now another thing we want to notice, or are looking for when we're looking at different types of graphs, is whether our function is even or not even. In the case of a function y equals x squared, it looks like this. It's got a very fancy shape. It looks like a parabola. How would we prove that this function is even, or how would we disprove it? So, if I draw it more carefully, you might be able to notice something. So, when I input the value 1, I get 1 squared. If I input the value 2, I get 2 squared, which is 4. And if you notice, if I input the x value -1, -1 squared is -1 times -1, which is 1. And if I input -2, again -2 squared, -2 times -2 is 4. So I get the same y value for the same value of x, but with a minus sign. So on the other side, you could say, of the number line. Now you might be able to notice a pattern here, or you might not. Basically, we say a function is even when our f of x equals our f of x with an inverted sign, with a minus sign. So in this case, x squared equals minus x, and then we just have to square it. So x squared equals x squared, which is true. Or, in more layman terms, if I put -1 squared and 1 squared, they're on opposite sides of the number line. They're the same values, their absolute value is the same. Their distance from 0 is the same, which is equivalent to saying their absolute value is the same. Then we can see 1 equals 1, and therefore our function is even. We can do it for other numbers like -2 squared equals 2 squared, which is 4 equals 4, and this is a proof of our function being even. Now, how do we prove a function is not even? Just let me move my screen quickly. So, if I have a function like y equals x, and again I'll graph the values. This is our x-axis, this is our y-axis as usual. What we notice is, again, there's a pattern emerging. So when I input 1, I get 1, and here if I input -1, I get -1. So the absolute value, or the distance from 0, is kind of equal, if you notice. So again, we have some sort of pattern emerging. It's not just for this number, it's for all the other numbers. You might have some functions where the pattern is applicable only for a small part of the function. If a function is even or not even on the whole interval, on its whole number line, then obviously all of the numbers have to abide by this rule. There are some functions where in some local regions you would say the function is even or not even, which kind of you could extrapolate that or find that out by yourself. It's kind of makes sense. So if I go back to what I was saying, we prove a function is not even when our x value equals this. So the negative value of the function and the negative value of x. So basically what this is saying in more simpler terms is that if I input 1, sorry about that, if I input 1 as my x value, and here I'll input -1 because I have a minus sign in front of x, and I plug this into my function, I will get 1 here, and here I will get -1. So all this is saying is that our function y at the end is going to have a negative value if we plug in the value -x. That's all for today, and next time I'll show you more about the properties of functions.